All right, so now we're going to move on to solving a system by elimination. So here is your how-to guide. Let's go through those and then we can apply them as necessary to our first example over here. So the first thing you want to do is make sure that both of your equations are in standard form. And standard form says your x and your y are on the left side and your constant, which is just your number, is on the right side. If any coefficients are fractions, you need to clear them. And we'll have an example of what to do when it comes to clearing them. And so the second thing that you want to do is to make the coefficients of one variable opposites. Okay, that's very important. This is very big. So basically, if you want to get rid of your x's, you're going to make them opposites. The y's, if you want to get rid of them, you make them the opposites. And so there's a couple of options that you have. So the bottom line is you have to make the coefficients opposite. So the first thing you would do in order to make that happen is sometimes it's already ready, but sometimes you have to decide which variable you want to eliminate. And then you either have to multiply one or both of those equations so that the coefficients of the variable are opposites. All right, so after you do that, then you just simply add the equations together. And when you do that, you're eliminating a variable. And then that means you are free to solve for the remaining variable. And then we just go back to the original step one, which basically says go back in to your previous equation and then solve for the other variable. Write your solution as an ordered pair, and then we're going to check it. Okay, so let's take a look at the first one over here. So it says to write both equations in standard form. If there's any fractions, we're supposed to clear them. So you can see that they are both already in standard form. So we don't have to do step one. There's no fractions, so we don't need to clear them. So we're done with step one. Step two says to make the coefficients of one variable opposites. Well, if you notice, I've got a positive y here and a negative y here. So that is already done for us. The coefficients of one variable are already opposites, which means we don't have to do the subcategory under number two. Then it says on step three that we're going to add the equations from step two. Well, there's nothing that I had to do differently. So what I'm going to do is just add the two equations together. So x plus x is 2x. A positive y plus a negative y gives me 0. And then it equals negative 3 plus a negative 11 is negative 14. And then I simply just solve. So it said right here, step 3, add. So I added. Step 4 says solve for the remaining variable. That's what I'm doing right here. So this is step 3, I added. And then now I'm solving. So I'm going to get x is equal to, I'm going to divide by 2. I get x is equal to negative 7. Okay, so that's very important. So I solved for the remaining variable, so I'm done. And then number 5 says, hey, substitute the solution from step 4, which in this case is negative 7, into one of the original equations. And then we're going to solve for the other variable. So at the very beginning, we had equation 1 and we had equation 2. It doesn't matter which one we plug in, so I'm just going to plug it in to equation 1. X plus y equals negative 3. I'm replacing x with negative 7 plus y equals negative 3. I'm going to add 7. I find out that y is 4. And now I am done with step 5. It says right here to write the solution as an ordered pair. So I am going to come over here and write my solution. Remember, it's x and then y. My x was negative 7 and the y is 4. And then the last thing we're supposed to do is to check. Remember, it has to be a solution to both equations. So I'm going to come over here and check. So equation 1 said x plus y equals -3. And equation 2 said x minus y equals -11. I'm replacing the x with -7 and the y with 4. And I'm checking to see what that equals. I get -3 equals -3, so we're good. I'm replacing x with -7. I'm replacing y with parentheses because there's a negative in front of it. And I'm checking to see if that's a -11. So I have -7. I'm simplifying this to be a -4. Does that equal -11? And yes, -11 does equal -11, so I know I'm right. Okay, so let's do this again with number 2. Same to-dos, right? Same how-tos. Um, it says to write both equations in standard form. If there's any coefficients that are fractions, clear them. So if I notice that I'm already in standard form, I've got my x, my y, and then my numbers on the other side. So step 1 is already done. Now, number 2 says make the coefficients of one variable opposites. So look to see if these coefficients of x are opposites. You can see that they are -2 and +2. If you notice that this one is a -1 and this is a -2, those are not opposites. So I'm done with step 2, and that is because the x's are opposites. So I don't need to do this step at all. Number 3 says to add the equations resulting from step 2 together. So I'm going to add the equations together. So -2 plus 2 cancels out. I get -1 plus -2 gives me -3y is equal to -3. And then I'm simply solving for y. I'm going to divide by -3, divide by -3. I get y is 1. Okay. So I ended up doing step 3 and 4. Those kind of lead each other together, right? So now we're going to substitute the solution from step 4 into one of the original equations. Well, equation 1 was -2x minus 1y equals -1. -2x minus 1 times 1. I'm replacing the y with 1. I'm just simplifying from here. I'm going to be solving, so I get -2x is equal to 0, and I divide by -2, and I get x is equal to 0. Just to recap real quick, it is okay if 0 is on top of a number when you divide, but it is not okay when 0 is on the bottom. So this is just a reminder. So I got 0 and 1. Now we were supposed to write that as an ordered pair, so it would be 0, 1, but we want to check. And remember, when you check, it has to belong to both. So -2x minus 1y, does that equal -1? So I am replacing x and the y, and I'm checking to see if it equals -1. So this gives me 0 minus 1 does equal -1. Now I need to do the other ones. 2x minus 2y equals -2. 2 times 0 minus 2 times 1, does that equal -2? I've got 0 minus 2, and yes, that does equal -2, so I know I'm right. So I box my answer there. All right, so again, I'm going to try this. Notice that on this particular says, write the equations in standard form. They are both in standard form, and there are no fractions. So I'm done with step 1. Step 2, make the coefficients of one of the variable opposites, and this is how you do it. So I noticed that my x is 2 and the other x is -3. Those are not opposite. This one is a y that's 2, and this is a -6, and they are not opposite. So I am going to have to do step 2 in more detail. It says now decide which variable you want to eliminate. Okay, so I can choose to eliminate the x, or I can choose to eliminate the y. So here's the logic behind this. You want the variables to be opposite. So We have to do that by multiplying either one equation or both so that the coefficients of that variable are opposites. So I'm going to choose to eliminate the y. If I'm choosing to eliminate the y, let's take a look. I've got a positive 2 and a negative 6. So what I want to do is I want to make this positive 2y a positive 6y. That's what I want it to become. So that way when I add these two together, they cancel. So I would need to multiply equation 1 by 3. So if I multiply equation 1 by 3, I end up getting 3 times 2x is 6x. 3 times 2y is 6y. And I also have to do it to the other side of the equal sign. Well, 0 times 3 is just going to be 0, so I luck out. And then I'm just going to copy down my next equation. That just stays the same, because now I got the coefficients to be opposite. So even though it took me a little bit, I just had to multiply. I am now done with step 2. And then number 3 says to add the equations together. So I'm going to draw my line and I'm going to add. 6x minus 3x is 3x. Positive 6y minus 6y cancel. And I'm left with 0 plus 9. I solve for x. I get x is 3. I just did step 3 and 4. Now 5 says to take your answer from step 4 and plug it into the original equation. So my original equation was 2x plus 2y equals 0. So 2 times x plus 2 times y equals 0. My x that I found was 3. So I've got 6 plus 2y equals 0. I'm going to subtract 6, and then I'm going to divide by 2. So I get y is equal to negative 3. Okay. So when I get y is equal to negative 3, I put it in the form of an ordered pair. That gives me 3, negative 3. But I have to check. So I get 2x plus 2y equals 0. And negative 3x minus 6y equals 9. So I'm just going to replace the x with 3 and the y with negative 3 and check to see if that equals 0. I get 6 minus 6 equals 0. Yes, it does. I'm going to replace the x again with 3, the y with negative 3, and see if that equals 9. So I get negative 9 plus 18, because 6 times 3 is 18. And does that equal 9? I get 9 equal to 9. Yes, so I know I'm right. Okay, let's take a look at the next one. Notice that this one's a little different. We have it written in almost standard form, except we've got fractions, so we need to clear them. So when you are dealing with fractions and you want to get rid of them, find your denominator and find the smallest number that they will all go into. So 3 has to go into the number, 6 has to go into a number, and 12 has to go into a number. So the biggest thing you want to do is start with the biggest number and see if 3 will go into that. Well, 3 will go into 12 and 6 will go into 12. So that helps me out a lot. That tells me I am going to multiply both sides by 12. Okay, so I am going to rewrite equation 1 as, well, 12 times 1 over 3 times x cancels out. The 3 goes into 3 once, and the 3 goes into 12 4 times. So I get 4x. But I also have to multiply this by 12. So 1 over 6 times 12. That goes in twice. So I've got plus 2y. And then I can think of this 12 and 12 cancel out, and I end up with negative 1. So The equation 1 is rewritten without fractions, and I'm so happy because I don't want to have to deal with fractions. So let's take a look at this second one. I've got a 3, a 2, and a 4. So you find the biggest number, and you ask yourself if the other numbers go into it. Well, 3 does not go into 4. 2 does, but 3 doesn't. So I'm going to do multiples of 4. So instead of a 4, can it be 8? Well, 3 doesn't go into 8, but 2 does. But remember, it has to be all of them. So now let's try 12. All I'm doing is multiples of 4. Okay, so I've got 12. Does 3 go into 12? Yes. Does 2 go into 12? And does 4 go into 12? So what I'm going to do is I'm going to multiply both sides by 12. Okay, so equation 2, 12 and the 3, the times the negative 1/3. 3 goes into 3 once, 3 goes into 12 4 times. So I get negative 4x. Remember, I also have to multiply this side by 12. 2 goes into 2 once, 2 goes into 12 6. So I have positive 6y. And then 4 goes into 4 once, 4 goes into 12 3 times, and it equals negative 3. So I've basically rewritten equation 1 and 2 without fractions. So it was a little bit longer process, but it's going to be worth it in the end. So I'm done with step 1. Now it says, hey, are there any opposites? Well, I luck out because I see that 4x and negative 4x are opposites, which means I'm done with step 2. So I am supposed to now add the equations together, which means these x's cancel. I get 8y is equal to negative 4. Divide by 8, and I get y is equal to negative 1/2. Okay, so I need to be able to reduce that. So I just did step 3 and step 4. Step 5 says to go into the original equation. I'm okay with doing it right here with equation 1, even though you should do the original. But equation 1 says 4x plus 2y equals negative 1. So I've got 4x plus 2 times negative 1/2. Does that equal negative 1? Well, actually, I'm not checking it. I'm actually solving for x. So 4x, 2 times negative 1/2 is negative 1. So I'm going to add 1. I get 4x is equal to 0. Divide by 4. Remember, it's okay if 0 is on top. It just means that x is 0. So my ordered pair, which is the next step, would be the x and then the y. Now, I should check. Very important. Go back to your original. Okay? So let's go 1/3 times, well, let me write down the equation first. 1/3 x plus 1/6y equals negative 1/12. So 1/3 times 0 plus 1/6 times negative 1/2. Does that equal negative 1/12? So this gives me 0. A negative times a positive is a negative, and I just multiply straight across. So does 0 minus 1/12 equal negative 1/12? Yes, it does. So now I'm going to go and do the second equation. Second equation is negative 1/3 x plus 1/2 y is equal to negative 1/4. So I'm going to replace my x with 0 and my y with negative 1/2 and see if that equals negative 1/4. So I've got 0. I multiply across. There's a positive and a negative, so it's negative. So 0 minus 1/4 does equal negative 1/4. So I'm good and my answer is correct. All right, so now we've got some context, some word problems. So let's take a look and see what this is. It says the sum of two numbers is negative 79. So what does that mean? I've got two numbers. Well, let's let x equal the first number and y equal the second number. And I'm taking this sentence and it says the sum, which means to add them. And the is means equals, and then it equals negative 79. So the first equation is going to be x plus y equals negative 79. The second equation says, hey, their difference is negative 3. So that means the second equation is x minus y equals negative 3. Find the two numbers. So now we have our system, okay? So from here, we're already in standard form, and it's easier for me to eliminate. Hopefully you're seeing this rather quickly now. I'm just going to go ahead and add the equations. I get 2x, the y's cancel, and I get negative 82. Divide by 2, I get negative 41. So x is the negative 41. So the first number is negative 41. And the second number, well, I need to go take that and plug it in. The first equation said x plus y equals negative 79. X is negative 41 plus my y. I'm going to add 41. And then I am going to get negative 38. And then negative 38 is my second answer. If I were to add these quickly to check, if I add them, I do get 79. If I subtract them, negative 41 minus negative 38 gives me negative 41 plus 38, which means they're different signs. And that gives me a difference of negative 3. So I know I'm right. So these are the two numbers. All right. Here we have not only a context, but they actually give you the equation for you, so that's nice. So what we're going to do is we're just going to look to see how we can take the paragraph and apply it. So a local community theater sells adult tickets, which is X. So again, I'm going to write X is equal to adult tickets. And it is $15. And then the children's tickets, which is Y, for $10. Okay, so I've got Y are the children tickets. Okay, so the adult tickets in terms of money is $15 and children's tickets are $10. All right. For one evening of the performance of a popular musical, the theater sells out 325 tickets and collects $4,000. Here's the system of equations. So I want you to understand one equation has to represent quantity, which is going to be the adults plus the children was 325 tickets. And then the other one, because we're talking about money, has to be in terms of money. So this is $15 per adult ticket, and this is $10 per child ticket, and it was a total of $4,000. So let's go ahead and solve this. These do not cancel right away, so I have to choose what I want to eliminate. So I am going to want to eliminate the x's, just a personal preference. So I need to multiply by negative 15 because I want them to be opposite. So that's going to give me a new equation 1 as negative 15x minus 15y. And if I were to do my calculator real quick and go 325 times 15, I'm going to get, first of all, it's going to be a negative, right? So a negative 4,875. Okay, that's 325 times 15. Equation 2, I want it to stay the same. So I've got 15x plus 10y is equal to 4,000. Now I'm ready to add. When I add those, the x's cancel. I'm left with negative 5y is equal to, and if I were to subtract those because the signs are different, I have negative 875. So if I were to take my 875 and divide it by negative 5. First of all, you have a negative and a negative, which means I'm going to get a positive. So 875 divided by 5 is going to be 175. So what does that mean? Well, the y is 175, which means the number of child tickets was 175 child tickets that were sold. Okay. So I need to find out how many adult tickets were sold. So I go back to equation 1, which says the adult plus the children's tickets equal 325. The X is the adults, but I know there were 175 child tickets. So now I'm going to take my 325 and I'm going to subtract 175 so that I can see how many adult tickets there were. And it looks like there were 150 adult tickets. So pay attention to what it's asking for.